Okay, all right. So here's what we're gonna do today. So today we're gonna do probably what? Probably some of the tougher questions, all right, of what we're doing right now with the FOIL method. Okay. So I'm gonna show you some examples, let you try a few, and then that's it. Okay. All right. So this is probably the last day we're gonna spend on the FOIL method specifically. Okay, so let's go. All right. Now, there aren't a lot of questions like this on the regions, maybe one. So I'm going to try to keep this lesson short, okay? Yeah, right. I've said that before. All right. So now I'll try. If I can do 10 minutes, man, I'll be so happy. All right. Okay. Now, I don't know if you've noticed. So one of the things I want you to be able to do right now for me is look at these three questions and you tell me how these are different from the questions we've done from, I don't know, like these, right? These. Like these questions, right? How are these questions? What I'm gonna do. Hold on. How are how are ay ay ay. Oh, why did I do that? Did I just all right. How are these questions? Hold on. How are these questions different from this? Yeah, notice these are binomials by binomials. These, I'll use my magic pen. These are binomials by trinomials. Now, I think, not what, 7, 8 months into the school year, you already know what I'm about to say, that it's not as hard as you think, all right? And that there is a fairly straightforward solution to this. Now, I would say this, all right? In my experience, all right, just even flashback to when I was your age, I typically find it easier. Now, the goal is still, here's the problem, okay? Problem number one, you can't use FOIL anymore, right? Because there's no like inside, outside, last. Well, there's still first, there's still last, but there's no like really inside, outside, right? Because there's extra term here, right? So do you see the problem here? So what we're gonna do then was we're gonna go back to what? We're gonna dial the calendar back a year and look specifically at using the distributive property. That's property, okay? That distributive property to solve this. Meaning this, take the term here, all right, where x is, and just start distributing to each of the terms that's inside the parentheses for the trinomial. Meaning this, right? X times x squared, that's x to the third, right? X times negative 2x, that's negative 2x squared. Maybe I should write this out, actually. Maybe that will help you guys, all right? So x times x squared, that's x to the third. X times negative 2x is negative 2x squared. And lastly, x times 2 here, right, a positive 2. X times 2 is 2x. So far, so good? All right, so I'm going to write that out too. Plus 2x. Now, here, I'm done with the first x here, right? I've distributed like the x to every item inside the other parentheses. So now I'm going to use a different color, okay? Here, I'm going to distribute a 3, and I'm going to just go underneath, okay? Because I don't want to start like a Star Wars, arrows everywhere. So 3 times x squared is 3x squared plus 3x squared, and 3 times negative 2x is what? Negative 6x. So as you can see, what's happening is once we added this extra term in there, it's actually the extra term actually is, yeah, okay, never mind. All right, it's like you see how much more stuff we got to do. So you got to be a little bit extra careful here. Here we got 3 times 2. That's 6, right? So plus 6. Now I'm going to combine like terms. So let's see, what is that? That's this, same family, Same family, same family. Okay, so let me use, now let's just go with the regular marker. All right, so x to the third. Now, negative 2x squared plus 3x squared is plus x squared, right? Because that's just 1x squared, right? And then 2x minus xx is negative 4x. And then this is just all there's left, plus 6, right? Notice, right? We have a polynomial, a 4-term polynomial, right? But now that the degree, right? Remember that word? The degree is 3, okay? It's an x to the third. It's like a cubic power, right? What else do I have to add? Yeah, that's it, okay? Now, here's a little tip. So what I'm going to do is I'm going to use this second one as 2 examples because I want to make a point here. Now, look at this. I know what some of you might be thinking. You might be thinking, well, for this one then, Mr. Ng, or even actually for this last one, right? Let's skip one. For this last one, you might think, oh, Mr. Ng, so let me just go like this then. Now, personally, I wouldn't do that. All right, I don't like, for some reason, I don't like multiplying 3 terms by 2 terms like this. So I'll give you an analogy. Think about it like this. Would you rather do this or this? You see the difference, right? So, okay, it's disappearing. All right, so because, why? Well, because we're just more used to doing like 2-digit time multiplying the 1 digit. Right? So now, does that affect you getting the correct answer? Really? Not really, because it's, the skill level is just not that, change, like, it's not that different. Whereas for this one, it's, I don't know, is it different? I don't know, it's just, I guess it's a preference, okay? And I prefer multiplying 2 terms, distributing a binomial, a 2-term expression into a multiple term expression like that. Okay? All right. Now let's see. What are we looking at here? Let's try this next one. Okay? So same thing. So I'll, what should I do actually? Yeah, okay. All right. So let's try one more together. Okay? Because, some of you might be intimidated by these sort of questions. So, okay. Again. Now, this time I'm not going to write all this stuff. Okay? So just try to listen carefully and watch what I'm doing. All right. Okay. So here we got x times x squared. That's x to the third. X times negative 4x. Negative 4x squared. All right. X times positive 2. That's positive 2x. So far so good, right? So those are all the blue arrows, right? That goes into each of the terms. Now let me switch color. I don't need to switch colors anymore. All right, second one, right? Because I'm done with this x here. So I'm going to take the 4 and distribute again, right? So that's positive, so 4x squared. All right, I think I know where this is going. All right, 4 times negative 4x, that's negative what? 16x, right? And lastly, 4 times positive 2 is 8. All right, combine like terms. Same family, same family, same family, same family. Okay, x to the third, and then what do we have? Now, these two are going to cancel out. Negative 4x squared plus 4x squared going to cancel out, all right? I shouldn't use the word coincidence, but it's, it happened, all right? 2x minus 16x, that's negative 14x. And then we got the plus 8, see? Now, you will notice that this one has 4 terms, this one has 3 terms. Don't look at your answer with the number of terms and like somehow think that's supposed to be right or that's supposed to be wrong. Sometimes it just happens. These terms cancel out. Okay? So here's what I want you to do. Now, for this one, hold on, I gotta turn the lights on. Hold on. All right, we're at the 9-minute mark already. So now for this one, it helps you. You can switch them around. All right? So try this one right now. Right? You can just distribute like, in that manner, so on and so forth. Right? You can go like that, like that, like that. All right, now the numbers, you know, the stakes are higher, right? Because I'm using bigger numbers, all right? Shouldn't be too hard. If you want to keep it like this, you can just draw the arrows like this, right? Right? So press pause right now, and then when you come back, I'm gonna go over these with you, okay? Actually, as a matter of fact, try 3 and 4 right now, okay? So, all right, try 3 and 4 right now. Okay, all right, and we're back. So here's what I'm gonna do. I'm trying to think. Okay, I would like to assume that most of you did it this way. So what I'm gonna do is this. I'm gonna go the other way, all right? So, you know, we're gonna zigzag. And I'm gonna go this way, you went that way, and then if our answers match, then, you know we're good, right? So, okay, all right. So let's see, negative times negative is a positive. 8 times 5 is 40. R squared times R is R to the third, right? And then I got to distribute it to this guy, so that's negative times negative, that's positive. 9 times 5 is 45, R squared. And then we got this guy, 9 times negative 5 is negative 45, R, okay? And then we'll do the same thing for the 1. 1, right? So that's negative 8R squared. That is 1 times negative 9, so that's negative 9R, and then this one is 1 times 9, and that's just 9. Okay, so far so good. All right, let's find the like terms. Let's see, which ones? Okay, all right, same family, same family, same family, same family. Now, what does that mean? That means I'm gonna write it over here. 40R to the third, all right, 45 minus 8, what is that, 37? Positive 37 R squared. Oh no, yes, okay. Oh, these are both 45, that's why. Negative 45 plus, negative 45 minus 9, that's negative what, 54? Plus 9, like that, all right? If you got that right, all right, I'll give you a high five right now, all right? So here we go, high five. Okay, all right. So now, moving on, last one, right? Am I right? Yep, okay. Now, this last one, I kind of make simple again. So we'll distribute, that's 3, 5, that's 15x to the third. So the only, I gotta tell you, as far as I'm concerned, you gotta be really careful with these exponents, okay? That's what I would say. 3x times 2x, 6x squared. 3x times negative 6 is negative 18x. And then 1 times 5x squared is 5x squared. 1 times 2x is 2x. It's nice when you're multiplying 1 to everything, isn't it? All right, that's that. Combine like terms. What is that? 6x squared, 5x squared, like that, right? Don't forget that negative there. 15x to the third, what is that? 6x, so that's plus 11x squared. All right, what is that? Negative 16x minus 6. And that's it. Okay, so if you did that, good job again. Okay, let's save this for class. Okay, because I want to end this at this point. So okay, all right. So thanks for watching. Have a good day, and I will talk to you tomorrow. Okay, all right, bye.
OMG, that was so good.